Okay, so I wanted to start another component for our front hub assembly, and I'm not going to make any of these tutorials about really complicated, intricate, 3D design stuff just yet, because I think that it's important to get the fundamentals down and be really comfortable with kind of the workflow of 3D modeling before you start to do any of these really fancy things that you might see on YouTube. So what I'm going to try to model today in the time I've got is a brake rotor, and that's going to fit on the front hub that we've already drawn. Now I don't have any of the measurements from the front hub, and that's okay, because I'm going to show you exactly kind of how parametric modeling can let us kind of do this way. So I think the first thing I'm going to do is I'm going to start off with a revolved profile, which I've done before. So we're just going to have to start off with a sketch on a plane. And it doesn't really matter which plane you start with. And we're going to start with a center line. We're going to make this our center line here. And brake rotors, floating brake rotors anyway, they always kind of have this general shape here. Okay, so they generally have this shape. This is usually a metric dimension, so we're just going to key in, call it 6 millimeters here. And I wanted to kind of make everything here parallel. So I don't think these are, okay, so these are constrained. You can see that they're perpendicular to that center line, and the center line is vertical. So these two are okay. Now these ones you can see are perpendicular to each other and perpendicular to each other. And this one is perpendicular to the center line there. Okay, so this is basically a horizontal line. But you can see that we're unconstrained in a couple other areas here. So what I want to do is create a constraint between these two lines and make them parallel. And then we can see that our model is pretty well, it's pretty well defined here. I don't know why that's doing that. Okay, anyway. Yeah, there we go. Okay. So I can start putting in some dimensions like we've done before. Okay, and our overall diameter for this brake rotor, I'm going to set at 320 millimeters. And I'm just going to kind of bring everything else into shape here. And this actually looks a bit wide, so I think what I'm going to do is make this 4.5 millimeters. It's a little more typical for a brake rotor, and the same here. Okay. And let's make this a little more realistic. And say we have a 10 millimeter offset there. And we can then define our angle. And let's say make that 10 degrees. And kind of bring the whole thing in here. And then the last thing I want to do is I want to make the hub face here kind of a known dimension, so let's call it 75 millimeters. Maybe call it 100 millimeters for now. Oops. Okay, so you see what I did there was, so if you ever do that, just zoom out, because what I keyed in is 100, and I forgot to put in, or actually I put in meters. Okay, so that can happen. All right, cool. So we got something, and I'm going to finish my sketch, and I'm just going to create a solid here by revolving that around, and then okay. And now the next part of the operation, we're going to start cutting pieces of this out. Before I do that, I want to add some fillets to make this a little smoother. And typically I'm not going to add fillets unless it's something I would do in terms of manufacturing, because my main line is really being a machinist. And I see a lot of drawings sometimes where people just fillet everything, and it's completely unnecessary and unrealistic, and it adds a lot of cost to the designs that you really don't need. So anyway, what I did there is I just selected all the edges that I want to round out. All right, and I'm going to put in my fillet value of a 10 millimeter radius. Okay, and you can see it's giving me a preview of what that'll look like. I actually think it would be better if they were a little smoother. So let's try 25 millimeter radius. Okay, I'm pretty happy with that. Let's go for it. Okay, so we've got our revolve feature. We've got our fillet. I'm going to call this the rotor profile. So just good practice again, name your sketches so that you know what it is that you're looking at when you go back to it. So the next things I'm going to be doing are subtracting, I'm going to cut holes out of this by subtracting. So I'm going to start a sketch on this main face here. And so the reason also, just to start really from the basics here, the reason I'm picking this is because I want to cut through the whole rotor, and this is my topmost surface. So I know that if I make any cuts in this rotor and my sketch is on this surface, I'm not going to have to try to cut in two directions, right? I can cut in just one direction from that face, and I can cut everything on the rotor. So I'm just going to right-click and create a sketch. And the first thing I think I want to do is I want to put in the hole that lines up the rotor on the hub. Okay, so let's call this 60 millimeters. Okay, and then I'm going to extrude that. Okay, and I need to select my profile, which is that. And I need to select my direction, which is that. And my extent, what I usually like to do is click all. And what that's going to do is it's going to say, say I change any of these features and maybe I make this further away. If I just had a distance extent, and I made the distance so that it's maybe a little past this bottom here, and then later on maybe I changed this, that extent is not going to change. So you may end up with a cut that doesn't go through the entire body. But if you go to that extrude through all, it's going to make sure that it always extrudes and cuts this entire object. All right, so the next thing, let's put some holes in that surface. So you see, I made one feature with that sketch there. It would probably be more efficient to make multiple cuts with that same sketch. So I'm just going to go back in here and edit. Okay, and I'm going to put my bolt holes in here as well. Okay, so the first thing I want to do is make these two vertical. And then I want to set my, well, let's do it the way I did it on the hub, right? I had a bolt circle diameter. So what I'm doing here is I'm drawing a circle, and I'm going to make that a construction line. And what I did is you see as I drew that circle, I pulled it up and snapped it to the center point of my bolt hole here. And it automatically snapped to that, and it created a constraint. So that's great. And now I just need to add my bolt hole diameter, which I think was a little over 10 millimeters. So we can call it 10.1 millimeters. Okay. And then I need a diameter for my bolt hole pattern. And I guess we can call it 70 millimeters. No, that's too small. Call it 80 millimeters. Sure, we'll give that a shot. And I know from my hub that I've got 5 of these holes, so I'm going to go back into Sketch Tools here, under Create, and a circular pattern. I'm patterning this object at that center point, and I want 5. Okay. And you see that even though I updated the sketch, I only have 1 hole there, and I can explain why that happened. So I'm going to rename my sketch first. Let's see, counting holes. All right. So what we want to do is we want to go back and edit this extrude feature. Because what happens is we needed to select all of the profiles created by our sketch. So it's not automatically going to pick all of these profiles. So you actually have to go back in and tell it what you want it to use to cut. Okay, so we've got that. And let's see, I guess we want to add some... We're going to make this a little more realistic, okay? So I'm going to make some more cuts from that surface. And this is a floating rotor, and floating rotors have kind of your brake rotor surface, and then they have a carrier, which is 2 separate pieces of material. So what I'm going to do is I'm going to cut this whole thing. All right, so let's call this 9.5 inches, and let's call, let me see if I can do this, dimensioning between circles. Okay, here, I can do that. And let's say I want 0.5 millimeter distance between my brake rotor part and my carrier part. Okay, so I've got both those things drawn. They're both black, so they're confined. So what I'm going to do is create another extrude, and then the profile I'm going to select is the profile between those 2 lines, and I want to cut everything, and my extent is all. Okay, now, so I made a cut through my part here, and you can see by looking at this that these are now 2 separate parts. And what has happened here is I've actually made 2 separate parts. So this component that I'm working with now has 2 solid bodies. Okay, so I'm going to rename these to the carrier, and then the brake rotor. Okay. And the next thing I want to do, maybe add some, features for lightening, lightening this whole thing up, right? So I'm done working on this part for now, so I kind of want to get it out of my way. So if you just click the eye icon next to that solid body, you can make it go away temporarily. Okay, so the next thing I'm going to do is right click here, and I'm going to create a sketch. So yeah, I think what I want to do is kind of draw some lightning features. So let's start off with a center line, because what I'm going to do is I'm going to pattern everything. So let's think about how we want to do this. Okay, so I think what I want to do is I want to have, let's say, kind of 5, or a pattern of 5 little lightning holes here, right? So we know that if we divide a circle up, 360 degrees, and you divide it up into 5, you wind up with 72 degrees. So what I'm going to do is I'm going to draw some other lines here, which are construction lines. And I want to make these 36 degrees apart, which gives us a total of 72 degrees. And I'm going to make these construction lines. So that means anything that I draw in this area, if I pattern it 5 times, then I'm going to have an even distribution of whatever it is that I drew. So let's just start off by making some lines here. Okay. And maybe I want a something a little more interesting for my pattern. Okay. Actually, you know what I'm going to do here? I'm going to do this way. Right. So let's make a little circle here. Make another circle over here. And okay, let's make this line intersect that circle, and make that line intersect that circle. So you can see that, some of the constraints that I can just drag and snap to, they're automatically going to kind of become constrained. It doesn't always happen that way. So sometimes you have to double check, but a lot of times it will, so that's kind of convenient. It makes your workflow faster. So I'm going to make these parallel, and I want to give an angle to this here. Let's call it 5 degrees, and I want to give some constraints to our circle. Let's say 5 inches, and make this 8 inches. And let's constrain this. So maybe 3/16 of an inch. And let's constrain this. All right. So now we're going to do some trimming. Okay. And you can see that we lost some constraints here, right? And now this thing is flexible. I didn't want that. What happened? So I guess we can undo. Okay. So I think I see what happened here, right? everything is constrained here, and then I made a trim, and then that became unconstrained. So I think I must have just run over my construction line here. Oh, no, I didn't. What did I do? Okay. Let's see. Okay, well, that's working now. Well, that was kind of weird. So I must have hit something, and I must have accidentally chopped this construction line. So anyway, we've got our little cutout, and I want to reflect it across that. So we're going to go back to our mirror tool. Mirror line, it's already selected. And then what I want to reflect is right here. So I'm going to click OK. And we're good. So again, I can either do this pattern in the sketch, or I can do it in 3D. So I think right now I'm going to do it in 3D. So what I want to do is extrude, pick my profiles. So I want these two. My direction, we just dragged it down. I want it through all. And we're cutting. Okay, everything's cool there. And I want to put some fillets in. So let's just select these. Now, also, SolidWorks does this cool thing where it will intelligently kind of, when you start picking stuff like this, it will ask you if you wanted necessarily to maybe pick all the corners in features. So it can save you a lot of time. I haven't quite found that in Fusion yet, so it might be kicking around somewhere, or maybe it's a feature they should add. So anyway, let's put a radius in of let's say a quarter inch. Looks pretty good. All right, cool. I can live with that. And now let's do our pattern. A circular pattern of features. And let's select the features. So that's our cut, and that's our fillet. We need to select both. We need to tell it what to revolve those around. And we need to tell it how many. Okay, so I told it 5, and then looks like we're good. Okay, so we've got some pretty little brake rotor there. Now I can turn back my other part of the drawing there, and that looks pretty nice so far. So the next thing is, when we're building a brake rotor like this, there are these little, they're called spools, and they're kind of a little rivet type structure that kind of bonds the outer rotor to the inner, and they allow them to kind of move relative to one another just a little bit, so as your brake rotor expands from heat, it doesn't start to warp and look like a Pringle. So what I'm going to do right now is I'm going to make the cuts for those, but I'm not going to put them in just yet. So again, I'm going to create a sketch right here, and let's say I'm going to want to have, let's just call it 5 for simplicity. You would never see a brake rotor with only 5 of these, but whatever. This is just for fun, or for learning, I guess. Anyway, okay, so what I'm doing here is I'm creating a line, and I'm going to make it coincident with our origin, and the line is also vertical. Now the next thing I want to do is snap the line to the inner and outer brake rotor. Okay, so Fusion is not grabbing that geometry. So I'm going to hide that. And then let's see if it'll, okay. All right, it's not selecting my part. That's really frustrating. Let me see if I can go into wireframe mode and find it. Okay, it's being a real pain in the butt right now. All right, I'm not entirely sure why it's doing this. Okay, so our carrier is there. All right, so it's these. All right. So our carrier is there. Let's just get out of that for a second. Okay. So this is kind of annoying. I'm not exactly sure why, Fusion is having problems with this. This is not a terribly difficult thing to do. Anyway, so let's create a sketch here. Okay. No, it's not letting me create a sketch. Boy, that's annoying. Okay, Autodesk guys. Your software is giving me fits. Well, that's pretty strange. Anyway, let's try this again. So I think what I'm going to try this time is projecting the geometry. Maybe I'll do include 3D geometry. Okay. Okay. So what I did there was I did include 3D geometry, and that kind of enables me to snap to three-dimensional objects that aren't necessarily on my sketch plane. Even though these two faces are on my sketch plane. So I shouldn't have had to do that, but I did. So I guess if you run into that issue, that's a good workaround for that. So the reason I'm putting this little construction line between the gap of my rotor and my carrier is because I want to have these spools centered in the middle of that gap. Okay, so what I did is I started the spool from the middle of that line, right in the midpoint. So that's going to tell me that the spool is centered in between these two. So I'm just going to give it some dimension, and let's say 16 millimeters. It's probably pretty close to what those are. I'm going to go ahead and finish that, and then do an extrude. Grab my profile. Now you can see, because it was broken up between these two kind of edges here, I have to pick two profiles. I could even pick the third one if I wanted to, but it's not quite necessary. So, if you go and try to extrude a sketch and you're wondering why maybe it only cut, half of your body, you need to make sure that you're actually picking all of the profile. So again, just go through all and cut and make sure it's going to cut both objects. It is. Okay. And we're going to do another circular pattern. Again, we're on features, circular pattern. Go ahead and pick my feature. All right, pick my axis. So I want it centered around that hole, and I want to get 5 in there. Close enough. Okay, so the next thing I want to do is draw my little spool feature. So if I can find a plane that runs right through one of these holes, that would be great. So let me take a look here and see if I've got anything. Okay, so the YZ plane runs right through. All right, I think first, before I get too far in, I'm going to start naming a couple of these sketches. Just because I'm already kind of forgetting which ones were which. So let's see, that is the cut sketch. So rotor, carrier, cut. Okay, and then this is my, let's call them lightning holes. So carrier, oops, I guess I don't have to call it a sketch. We know it's a sketch. And then this would be the spool hole. All right, that makes a little more sense. All right, now I'm going to go back and right-click on that plane to create a sketch, and Control-7 to bring up my wireframe. And let's see, we want this dead center. So let me see if I can just grab this geometry. Okay, I can't. So snap, I don't think snap's going to do it. Okay, so again, I've got to go in here and I've got to include 3D geometry. So that should enable me to snap to this stuff. Okay, well, okay, not quite. So I included the 3D geometry that was the, I guess, this face and this face. So that's not actually what I wanted. So when I include the 3D geometry, I've got to pick this, that surface right there. So let me go back to shaded mode. So what I did the first time is I picked this surface, and what it did is it gave me all the edges of that surface, except for the ones that I wanted, which were the edges of that surface. So I hope this is kind of making things sort of clear. You know, Fusion has, you know, kind of interesting ways of doing things. So it's a bit esoteric, but I think once you kind of get the idea of what tools you need to get to, that can make things a little easier. So again, I'm going to turn that into a construction line, and let's go ahead and just draw a little spool, right? Now, this doesn't have to be terribly accurate, and it doesn't have to be as detailed as these things are, because these are actually made up of a few different parts and they're crimped together, so we're not going to draw all that. This is just an exercise. And what I'm going to do is start giving some little clearances. That's probably too big. Let's say 8 millimeters. Okay, and I want this to be lined up on the center. Okay, so I'm going to have to go ahead and pick some more 3D geometry. Let's see. Guess I can include that. And sure, why not? Okay, so I'm still not able to pick anything on, like what I'm trying to do here is I want to make some clearance between this hole and the inside of my spool. I can't do that by just projecting or including the 3D geometry. So what I'm going to do is an intersection, and that will allow me to pick that surface. Okay, and now I've got some geometry shown in purple that I can dimension from. So we can do that. And I can also take a midpoint line, which you can see it just snapped to the midpoint. And I want it on that midpoint. I want that to be a construction line, and I want this to be vertical. Okay, so what that's going to do is it's going to center this whole thing on the rotor, because I've got a midpoint vertically constrained over another midpoint. And I want these to be the same diameter, so these should be collinear. And I'm going to draw a center line because I'm going to revolve this spool. Okay, and I'm going to do a midpoint. So this line extends from kind of one edge of the hole to the other edge of the hole diagonally, so I know that the midpoint of this line is in the middle of this hole in both directions. So now I've selected my center line, and I've selected my diagonal line, and I'm going to click midpoint, and that's going to make both their midpoints coincident. All right. So that means that if I revolve this spool around this line, it's going to be right in the middle of that hole. So let's add some more dimensions, and we're going to go ahead and do that. So let's call this 13 millimeters. And we've got that dimensioned. So we just need to give us the outer diameter there. So let's call that 18 millimeters. Nope, let's call that 20 millimeters. All right, good enough. And yeah, strangely enough, the sketch is still showing up in blue, and I'm not entirely sure why. But when you go to try to move anything, you can't move anything. So that's telling me it's constrained, even though the graphics seem to be not quite indicating that. In any case, so I'm going to finish the sketch and then create a revolution. Okay, so pick that profile. It's already selected the axis. New body. Okay. Cool. And let's go back to our shaded view. Right, everything looks good. And I want to do another pattern where I'm going to move those to each one of those holes. So again, circular pattern we're doing. So this is a new body. Okay, so instead of doing a feature as the object type that I want to pattern, I want to make sure I select bodies. right? And I'm going to go ahead and pick that. And then the axis, I'm going to pick my bore, and I want 5. Okay. So that looks pretty good so far. The only other thing I can think of is that usually brake rotors aren't going to have, they're not going to have this really close surface. They actually kind of, they come to a point around these spools. So just for realism, I think I want to add another cutout here. So again, I'm just going to create another sketch. And let's do a new feature that we haven't done yet. So what I'm going to do is a slot, and I want to do a center point arc slot. Okay. So let's see. So you can tell by the hint what it's asking me for as far as, picking stuff. So it says select center point of arc. So I'm just going to select the my rotor center. So and select start point of arc. So I want it to be right about here. Select end point of arc. Okay, let's call that there. And then drag it out. And you can see that what I did is I drew it. It's not in the right place. That's fine, because this is parametric. So I'm going to kind of flesh this out as I go here. Okay, so first thing I want to do is I want to create some construction lines that are going to define our start and end point. Let's see. So the way I'm going to do this is I'm going to use my spools here as a reference, and then I'm going to make the start and end point of the arc a certain angle off that spool. Okay, so these are going to be construction lines, and I want this to be, let's say, 15 degrees. That looks fine. And the same thing here. Okay. Now, one of the things that I can do, because I'm trying to put this thing dead center in the middle of our gap here. So I could go through and I could pick this geometry and I could project it, and then I could draw a construction line and do all that other stuff, which took some time. But the midpoint of this spool here, I know, is right in the middle of that. So I can use some geometry that's already here and save myself some time, right? So what I'm going to do is take my arc center here, which is the center of that slot, right? And I'm going to take this point here and shift click it, and I'm going to make them coincident. Okay, so that essentially took this construction line that my slot is drawn on, and it made it the same diameter as this spool location, which is exactly what I would have had to do manually. But that data was already there, so I can just grab it and use it. Okay, so let's give this a radius. Let's call it 8 millimeters. And I actually think it might look better if this were a little closer in. So let's call that 10 degrees. And same thing here. I'm going to finish the sketch and then extrude both these profiles, put it through everything, and then click OK. And again, I'm going to do the circular pattern. We're going to go back to features, as opposed to bodies. So I've selected that feature. I'm going to select the axis, and I want 5. And I'm going to click OK. All right. So one of the other things that Fusion can do, which makes your drawings a little bit it makes them either more realistic, or it can make them a little bit easier to interpret and understand, is you can add some color and texture to things. So in SolidWorks, I have kind of a palette of certain colors for certain parts. So you can definitely do that, or you can just make this rotor look a little more realistic. And the way we're going to do that is, first I'm going to name these bodies to make them a little bit clearer. All right. Let me see if I can name them the same thing. Ah, cool. So SolidWorks would just kick an error at me if I tried to do that. Fusion is kind of nice. It's going to give me a number automatically. That's kind of cool. I kind of like that. All right, so let's make our carrier a certain color, right? So what I did is I just right-clicked here, and you can go down to Appearance, and let's see, you can go in Fusion 360 Appearances, and let's see if we can find something that looks good. Okay, so I'm not seeing anything that looks good. I kind of want like a gold yellow look. Huh. All right. That's interesting. So it kind of makes me wonder if maybe I can create my own colors or my own patterns, maybe. That would be nice. Maybe we just drag bronze on there or whatever. So the way that you do that, you just you saw me take this and drag it on there. It's pretty easy. And let's see, maybe make our rotor something a little different, just for fun. How about stainless, brushed, satin? Stainless steel cast. Let's see what that looks like. Okay, cool. Well, whatever. All right, so we've got a rotor. We're done with that. Now we can save this, and it's going to go in Fusion Tutorial. Let's call it rotor. All right, now we can close that, and I can go in and pull up my wheel hub again. And what I want to kind of show with this is how to import another drawing or another part that I already made. So I think it's going to be under New Component, or Export, Assemble. New component, standard component for external. Yeah. Okay, so this doesn't work the same way it does in SolidWorks. So I guess the way that you do this in Fusion is you just go into your design thing here, and you just drag stuff in. So, okay, I can get behind that. All right, so let's just throw that in there. All right. So again, what I'm going to do here is I'm going to create a rigid joint because we went over joints before. So I'm just going to go and make one. So we're going to do a joint. Again, remember, we're going to select this surface and we're going to control and then go over to the middle point of that surface. And then our rotor would normally line up on this surface where the bolt holes are. So again, control and then click there. Now under motion, we currently had a slider joint selected. I want this to be rigid. So we can just go ahead and do that. Now there's going to be a little bit more to it, and I will maybe show that in another video, but there's a way to get these holes to line up. So you can mate to, like you can mate so that the bolt holes will also line up. This isn't terribly realistic because it's locked in place, but you know, the holes don't line up, so it doesn't really do anything. Anyway, so that's that. We got a little thing going here. All right, have a good night.